At tutorial sheet 6, question 1, we have been discussing about the electric potential difference due to a point charge and electric potential energy. So let's see how we can calculate or solve problems using what we have learned. So tutorial sheet 6, physics 1 or 2. Question 1 says, a 35 microcoulomb point charge is placed 32 centimeters from an identical 35 microcoulomb charge. How much work would be required to move a 0.5 microcoulomb charge from a point midway between them to a point 12 centimeters closer to either of the charges? So the first step in tackling this question, as we did in my previous video, is to draw a diagram. You draw a diagram which illustrates what is happening in the question. So in this question, they are saying we have 35 microcoulomb charge. So you indicate that 35 microcoulomb charge on a diagram. So we are going to draw a charge Q1. You name it Q1, and then you draw it. And then it is 35 centimeters away from another charge. In this case, it is identical. This charge is identical. So if it is identical, then it will be also 35 microcoulomb. So you draw that charge, you represent it as Q2, and then 35 centimeters away. Then from there, the question now reads how much work. It is requesting us to calculate the work required to move a 0.50 microcoulomb charge. So this charge is moving from a point midway. This statement here, very important statement, from a point midway between them. So between these two charges, the point midway is the point 16 centimeters from each of these charges, because it is 32, so half will be 16, so the midway will be 16 there. So from that point, moving between them to a point 12 centimeters. So from that point to a point 12 centimeters closer to either of the charges. So that charge Q3, it has moved from here to a point 12 centimeters. Okay, so what they are requesting us to calculate the work done in moving this charge from this point to that point. That is the diagram. So how can we find the work? So to find the work, we first need to calculate the potential difference. The potential difference here at that point due to these two charges, and then we also find the potential difference at that point there, and then from there we replace in the equation or the formula for work, then we find the work. So let's first find the potential difference here due to these two charges. So the potential difference there will be V1. Let's say it is V1, and this other potential difference at where that charge is will be our V2. So our V1 will be the potential difference due to Q1, which will be VQ1, plus potential difference due to this charge Q2. So let's represent it as VQ2. So we know that potential difference due to a point charge is given by K multiplied by Q1 over R, which is charge over the distance R from the point of interest there. That is the distance R, which is 16 centimeters. So 16 centimeters, you convert it to meters. So to meters, it will be 0.16 meters. Okay, and then from there, our VQ2 will be K charge Q2 and the distance R2, which is the distance from Q2 to the point of interest there where we want to find our V1. So let's now replace the numbers, but before that you can factorize our K. Factorize our K will be that side K, and then our Q1 over R1, and then Q2 over R2. So replacing the numbers, our K, we know that is simply a constant, and it is 8.99 by 10 to the power 9 newtons per Newton meter squared per coulomb squared. And then our Q1 is 35 by 10 to the power negative 6. Remember, there it is micro. Micro is simply 10 to the power negative 6 coulombs over r, which is the distance. Remember, it is 16, so it will be 0.16 in meters. And then our Q2, since it is identical, it will be 35 as well by 10 to the power negative 6 centimeter, not even centimeter, but coulombs. And then over R2, since it is midway, then it will be 0.16 meters. So punch this on your calculator, then multiply it to the constant. This constant, which is 8.99 by 10 to the power 9. Then you are going to find that our V1 will be just 3.938 by 10 to the power 6 volts. So we have found our voltage or potential difference at this point. Now let's find our V2, which is the potential difference at that point due to these two charges. So to find that, we are going to use the same method, but now the distances will be, the distance from Q1 to Q3 will be 16 plus 12, which will be 18. And then the distance from Q2 to Q3 will be 4 centimeters. So we use the same formula, then we factorize K. So our Q1 will be the charge Q1 over R3, which is the distance now from Q1 to Q3 there. And then from there, our Q2 will be the charge Q2 over R, which is R4, the distance from this charge here to Q3, which is 4. So replacing the numbers, we are going to have our constant, which is 8.99 by 10 to the power 9. And then in brackets, we are going to have our charge, which is 35 by 10 to the power negative 6 coulombs over the distance, which is 28 centimeter. Now in meters will be 0.28 meters. And then here our charge over the distance 4 centimeter will be 0.04 meters. So punching this on the calculator, we are going to find that our voltage, which is V2, will be 9 by 10 to the power 6. So having found the V1 and V2, the work done in moving the charge will be given by the formula, that charge, which is Q3, multiplied by V2 minus V1. And then our V2 is 9 by 10 to the power 6, and our V1 was 3.938 by 10 to the power 6. So replacing those numbers in this formula, you are going to find that the work done in moving that charge will be 2.5353 joules. So that's how to solve that question. Thank you very much for watching. Remember, don't forget to like, subscribe, and leave out your comment concerning this video in the comment section below.